Good afternoon, everyone. Today we're going to look at a quadratic function, namely y is equal to x squared plus 7x plus 10. We're going to find the vertex in a couple different ways and all of its intercepts, namely its x and y intercepts. So, as far as the intercepts go, the first one that I always find, the easiest one, is the y-intercept, right? The y-intercept we find by simply plugging in x equals 0, right? Because that's when our function crosses the y-axis, when x is 0. So, when x is equal to 0, y is equal to 0 squared plus 7 times 0 plus 10, right? So y is equal to 10. So we have a y-intercept at 0 and 10, right? Now our x-intercepts, those are our roots, and so we find those by factoring this quadratic and then solving it in factor form. So we think, back to grade 10, two numbers that multiply to make 10 and simultaneously add to make 7, right? That'll be 5 and 2, so x plus 5, x plus 2. And so the x-intercepts are when we are on the x-axis, right? And if we're on the x-axis, then y is equal to 0. And so we set y equal to 0, and we get 0 is equal to x plus 5 times x plus 2. Now you know that for two numbers to multiply to make 0, one of them has to be 0, at least one of them, right? So either x plus 5 is equal to 0, or x plus 2 is equal to 0, right? That's the only way this can work. And so if that's the case, then x is negative 5, and if that's the case, then x is negative 2. So our two x-intercepts are negative 5, 0, and negative 2, 0. So now if we're sketching this quadratic, we can start to pop this on a graph. Negative 2, 0, let's say that's here. Negative 5, 0, that's around here. We have our y-intercept at 0, 10, which is maybe around here, right? This starts to make sense. Now, the vertex is going to be smack down in the middle of the two roots, right? So, since we know our two x-intercepts are at negative 5 and negative 2, vertex, because quadratics are perfectly symmetrical about the vertex, that's why we consider our axis of symmetry to be the x-coordinate of the vertex, right? The vertex is at the average of the two x-intercepts, right? Because if our quadratic is going to be symmetrical about the vertex, then it needs to be right in the middle of the two x-intercepts, right? That's the only way that's going to make sense. It's the only way it's going to work. And so where is the middle of negative 5 and negative 2? Well, you can think of that as the average of negative 5 and negative 2, right? And to get the average of any two numbers, we just add them together and divide by 2. And so that means negative 7 over 2. And so x is negative 3.5, okay? I'm sure another way you've learned it is negative b over 2a. And that'll give us the same value. Negative b means negative 7 over 2 times a. The leading coefficient is just 1. That's negative 7 over 2 times 1, which of course is again negative 3.5. And so now we have the x-coordinate of the vertex. However, we don't have the y-coordinate, right? To get the y-coordinate, like any other y-coordinate, we can just plug in the corresponding x-coordinate into our function, right, and get the corresponding y value. That's a bit of work, but it's not the end of the world. However, since we're doing it, another way we can do it is we can complete the square, and that'll give us the vertex right away. So to complete the square, I'm sure you learned it as we look at the first two terms first, and we do x plus half of the b value. Half of 7 is 7 over 2, right? So we'll have x plus 7 over 2 all squared, and we have plus 10 later on. And now, you know that if I expanded x plus 7 over 2 all squared, we would get x squared, then we get plus 7 over 2x, plus 7 over 2x, so plus 7x again, right? But we also have a new constant term at the end, right, that we didn't have previously. We'd have 7 over 2 times 7 over 2, that last bit would make 49 over 4. That we just kind of created out of nowhere, right? Because it was convenient to do so. And so we need to balance that out, and we need to subtract it, right? Because 7 over 2 times 7 over 2 is going to be positive 49 over 4. Of course, we balance it out with subtracting that amount. And now we can simplify these two terms, right, because they're both constant terms. And so we can rewrite our quadratic in the form of x plus 7 over 2 all squared. Negative 49 over 4, that's negative 12 and 1/4. So negative 12 and 1/4 plus 10 is going to leave us at negative 2 and 1/4, or if you'd rather, minus 9/4. And this, we call that in vertex form. And so this provides us with the coordinates of our vertex right away. And so we have our vertex at, remember we flipped the sign of the x coordinate inside the bracket. And so negative 7 over 2, which we found two different ways already. Negative 7 over 2. And now the y coordinate, if we plugged in negative 7 over 2 into the original equation, that's what we would find for the y value. Bit of work. We can read it right off when we have it in vertex form. And so the y coordinate is negative 9 over 4, negative 2.25. And that makes sense because negative 7 over 2 is smack dab in the middle of negative 2, negative 5. Negative 2, negative 5. And negative 9 over 4, that's around negative 2.5, something like this. And so that's around here, which makes sense because we have a positive leading coefficient, right? Positive 1. So this is going to be a quadratic that opens up. And so the vertex is going to be down here at a minimum point, and then it'll spring back up. We know the quadratic function is symmetrical about its vertex, right? Hence its axis of symmetry. Axis of symmetry at that vertical dotted line. That's simply the line x is equal to negative 3.5, or x is equal to negative 7 over 2, right? And since it's perfectly symmetrical about the vertex, that means that 3.5 units to the right, it's at 10. We found that out from getting the y-intercept. And so that gives us a free point, if you want to think of it that way. We usually ask for 5 points when we're sketching functions. So if 3.5 units to the right of the vertex, we're at 10. Same applies on the left side. And 3.5 units to the left of negative 3.5, we're over here at negative 7, somewhere around here. And so our fifth point is going to be somewhere around here at negative 7 and 10. And now you can sketch that quadratic, and it looks something like that. So that's about all the information we can get from a quadratic in standard form. I like writing in vertex form to easily read off the coordinates of the vertex, factoring it to get the x-intercepts. Y-intercept is always straightforward. If you want to use a different strategy to get the vertex, you do have options available, either by the symmetry of quadratic functions about their vertex, meaning that their vertex is always smack dab in the middle of their two x-intercepts, or the more crude x is negative b over 2a for the x coordinate of the vertex, and then plugging that into the original y is equal to equation to get the corresponding y coordinate of the vertex. Now, we usually sketch it with 5 points. These are the traditional 5 points. So I hope this helps, and thanks for watching.